Good day, guys. So today I'm going to take Newton's interpolation method, but we're going to delve into divided difference method. Now, according to the mouse note, we have two methods being taught for Newton's interpolation, that is divided difference and forward difference method. Now, for you to know when to use any of these two, if you're given a question, you check the value of your x. Like if the difference is uniformly distributed, then you use forward difference method, or if the value of your x is constant, you can use forward difference method. But whereby the situation is not like that, you use divided difference method. That's the easiest way to know when to use divided difference and forward difference method. Now, for divided difference method, let's assume that this is an interpolation of a discrete data from x0 all the way to x3. Now, I can assume that between x0, y0 to x1, y1, there is a linear interpolant here. There is a linear interpolant here, and which is obviously yes, because it's like saying from point A to point B, it is linear. You get? So that's for this one. Then for quadratic interpolant, it means that it is moving from x0 down to x2. This makes it a quadratic interpolant. It's not just between one more point now, it's between two other points. So this makes it a quadratic interpolant. Now for the last one, which is x3, this is called the third order polynomial interpolant, because it has what, three other points to connect with. So assuming this, taking this linear interpolant, I can say that this place is my f of x. This is my f of x. So if I'm going to find my p1 of x, it is going to be f. Now this is the general formula for linear interpolant, that is interpolation between just 2 points. This is the formula for it. Now, what does this mean? In some textbook, you can see this p1 x as same thing as f1 x1 or f of x1. You can see it like this. Now from this, we all know that looking at this graph, I can say that y is a function of x. Obviously from our calculus days, y is a function of x. So looking at this, I can say that this f of x0 is the same thing as my what? Y0, and this is my y1. Now looking at this is the only missing or value that I need to find, which is my f of x1 comma x0. Now the easiest way to find this, just draw a line, take the difference, the range between the two, starting from the highest to the lowest, and the highest is about x1 minus x0, and then find the difference also between your f of x1 minus f of x0. Yes, this is how you get your f of x1 comma x0. Very simple. Now the next one I'm going to is my p2 x2. Now looking at this, I can say this is my what? y2, and this tells me that this is a what? Quadratic interpolant. Now what I need to do is consider this graph. It is starting from what? x0 to x2 comma y2, not from x0 comma y0 to x1 comma y1. It's going all the way to x2 comma y2. So now the first thing I will do is I will consider the interpolant from here to here, and also from here to here, and we will know the interpolant from here to here, because from here to here is a linear interpolant. So I can just write this and then find the interpolant from here to here. So this is the formula. Don't get it twisted. Remember, this is your y0, and the whole of this is your y1. How? This f of x0, like I said, your y0 plus f of x1 comma x0, that is from x0 to x1, into bracket x minus x0. And this one, it is x minus x0 because it is one data point, that is P1. It is one data point, all the way to plus f of x2, x1, x0 into brackets x minus x0 to bracket x minus what, x1. Why is it x minus x0 and x minus x1? Because it is two data points. That's what we're looking for, what, P2. It is two data points. That's the easiest way to understand it. Now, what is the value I'm supposed to find here? There are two values, this one and this one, but you already know this one from here. So if I'm going to find this f of x2, x1, x0, so this is making me understand that my numerator is going to have a function of two values. What I mean is, first and foremost, I'll draw my denominator, then the range, that is from x2 to x0. Now the two data point, the two values I'm talking about is going to be from x2 to x1 and x1 to x0. Remember, from this one it was just x1 and x0 because it was one data point, but for this one, since it is two, it will be a function of what, x2 x1 minus f of what, x1 x0. Shaking up. So if you're going to find your f x2, f of x2 x1, just do it this way. So I'm going to find P3 of x. Now it is from here down to this place, so that means I have y1 in it, I have y2 in it. So my y0 is what, f of x0. This is the one I need to find the value for, because I found for this one and I found for this one. So f of x0, x1, x2, x3. Now this is 1, 2, 3, 4. That's 4. But because it is a what, 3 data point, it means that my numerator is going to have three variables. You get? So don't forget your range is x3 minus x0. Sorry, for easy understanding, let it descend instead of it to ascend. What I mean is, this is x3, x2, x1 and x0. You can write it anyhow you want to, depending on how you understand it, but me, this makes it easier for me. So this is f of x3, x2, x1 minus f of what, x2, x1, x0. This is how you find this value. You already know this one. And if you don't know it, you can find it simple by using the quadratic interpolants.